Today we are going to begin the machine learning section of the course, and over the next maybe 2 lectures or so, 2 to 3 lectures, we're going to look at the problem of classification. So i- before we transition to the machine learning section, here's a way you can think about how classification can be useful in information retrieval systems, because what we're going to discuss today is not going to build upon what we have done so far in the course. It's going to be a somewhat different topic, but it's still related to IR and to data mining, and I just want to give an introduction to classification so that this transition is a little smooth. So much of what we're going to cover today corresponds to chapter 13 of the book. It corresponds to a section of that chapter. We're not going to cover the whole chapter. So you can, if you want to read up, material related to this, you can read up the first half of chapter 13. So suppose there is a topic that you want to track, and that could be a very contemporary topic, like for example, the ongoing agitation in India by Anna Hazare. Let's say you want to track a current topic like Anna Hazare. Uh, One thing you could do is to keep entering Anna Hazare every day in the morning on Google search and find out what new news articles are there about him, or what new blog articles have been published. What is the new content about Anna Hazare today? That's a question you can ask, and you can do a Google search on that. But actually, Google provides you something called Google Alerts, which is a system which will only return you results about a topic from documents that have newly appeared on the web in the last day or so. So unlike normal web search, where you have an ad hoc query, that is, suddenly you have an information need, like for example getting rid of mice, and then you translate that information need into a particular query, enter it on Google search, you get some set of results, you browse a few of those documents, and your information need is satisfied, and that's it. You are no longer interested in that particular topic because the specific information that you are looking for has already been returned. So that's called an ad hoc search, where you have a one-off query to a search engine followed by browsing of the results and satisfaction of the information need. A standing query is a query that's pretty different, because a standing query represents a query on a long-term interest, uh, uh, on topics of long-term interest to you. Like for example, Anna Hazare, or you could be interested. Let's say you're a biologist. You could be interested in latest journal articles that have appeared on the protein that you do research on. Or if you are a person working in some intelligence agency, you may want to keep track of certain individuals, any information about those suspected individuals that appears online on the web. uh, so that's called a standing query, where you want to execute your query against a search engine very regularly, periodically, and Google Alerts allows you to do that. So if you just type Google Alerts and go to the page for Google Alerts, you can enter topics of long-term interest to you, and every morning you can get an email where you can browse the results about that particular, or those particular topics of interest to you. So how does a standing query get executed against an IR system? Well, one simple modification of what we've done so far is to think of all the articles that have been that have appeared on the web in the last 1 day or so as entering a separate index, something like a dynamic index that we talked about in one of the earlier chapters. And then you can take your query and execute it only against that particular dynamic index. Or if that index has older documents also, then you can maybe use some kind of document metadata, like the date of uh, the date at which, or some kind of a timestamp on the document to indicate when it entered the index, and you can only uh, focus your attention on those documents that have been added to the index after a particular timestamp. So that's one way to handle standing queries. Another way to handle a standing query, which may make more sense for a more general topic, like for example China instead of Anna Hazare. Anna Hazare is of course a very specific topic. It's an individual about whom you want information. But let's say you want information about a broader topic like China. Now, not all documents that appear on the web in the last one day having the word China in them are going to be relevant to you, because there could be a book that newly appeared on the web in PDF format which mentions the word China just once somewhere inside. Now that's not going to be something relevant to you, because you really want articles, you want documents whose main topic is China. So you can think of answering such queries as a classification problem, where you want to classify all the documents that are recent into two classes. Either they are on China or they are on some other topic. And you want to focus your attention only on those documents that pertain to the topic China. So this can be thought of as a text classification problem. So another example of a classification problem that you would encounter on a daily basis is spam filtering. So if you use Google, Gmail or Yahoo Mail, your email system itself filters out a number of incoming emails into the spam folder. Sometimes uh, even some legitimate mails may enter the spam folder, as you may have discovered if you happen to browse your spam folder occasionally. So how do you classify a particular incoming email as spam or not spam? That's also a classification problem. So here's an example of an email that is clearly a spam mail. So what we're going to talk about today is the classification problem as it applies to text, again to web documents. The classification problem is a more general problem than this. It appears all over the place in all kinds of domains, but we are going to focus our attention to text classification. And we are going to focus our attention on one particular algorithm for classification called the naive Bayes algorithm. That's going to be the thrust of this lecture. So here's a definition of the problem of classification. It's also sometimes called as categorization. The two mean the same thing, whether you call it as categorization or classification. The broad problem is the same. The problem definition is as follows. You have a document D. Okay, it could be a new document that has appeared on the web, let's say, and it belongs to a set X. So this set X is the set of all documents that have appeared uh, within the last one day or so in the index. And D is one particular document out of this set. Now you have a predefined set of classes. Okay, you have a predefined set of discrete classes C1 to Cj. Okay, and these could be spam or not spam. Okay, so you can have two classes, one standing for spam documents, the other standing for non-spam documents. And by spam here I mean documents that have been deliberately fudged with or crafted so that they appear high in the search engine rankings. They don't really have any meaningful content on them. So you can have that kind of spam, and of course you can also have spam in the context of email. Or you can have two classes, one class representing the documents related to China and another class representing documents not related to China. Or let's say you have a set of predefined classes to categorize news articles. You can have one class for politics, you can have one class for sports, you can have one class for international news, and so on. So these classes are predefined and they are finite in number. And what you want to do is you want to classify this new document, this particular document D, into one of these classes. Okay, so you want to come up with some function which is represented as gamma here, which will map this document to some class within this set of classes. Okay, and we want to understand how we can build a function that does this classification accurately. And that brings us to a general problem called to a general approach called supervised learning, which is one category of machine learning algorithms. So what is supervised learning? Supervised learning is a set of machine learning algorithms where you first train the machine to recognize typical examples belonging to each of these classes. Okay, and then the machine will look at several such examples of documents belonging to each of these classes, and you are going to label those documents with the classes they correspond to. Okay, so the machine is not just being provided information about it's not just being provided these example documents which belong to these classes. They are explicitly labeled as belonging to these classes, so clearly some human will be labeling them. Okay, and that's provided as an input to some machine, and then the machine is going to learn to recognize patterns characterizing each of those classes, so that in the future when you have a new document, the machine will the machine would have learnt what are the typical characteristics of each class, and then it's going to take that new document, recognize what patterns that document has, and map it to one of the classes based on what it has learned. So this is called supervised learning, and the reason it's called supervised is because it has two distinct phases. This algorithm, there is a training phase, and in the training phase you are providing a series of labeled examples to the machine. Okay, so you are like a supervisor who is providing a set of labeled examples to the machine, which the machine is reading, and then it's building a model. It's kind of building some kind of a representation of each class inside its head, uh, recognizing certain distinctive features about every class. And then after this training phase ends, there is a second phase called the test phase, which is the phase where you actually have new documents that have not been seen earlier by the machine. And then the machine is going to take these documents and then classify them into one of these predefined classes. Okay, now supervised learning is not something that's restricted to classification. Um, it's a more general class of machine learning algorithms where you have these two phases. I just explained how these two phases apply to uh, the problem of classification, but here's another problem which is actually not related to classification. Um, let's say you want to predict what the price of a house is as a function of the area of the house. Okay, so you can have data about the price of houses as a and the area You can have a set of examples of houses that have been sold in the past, knowing what area those houses had and what price they were sold at. And based on those examples, you can plot them in this 2D graph, and you can get some kind of a pattern like this. Now, let's say your goal is to predict the price of a new house that appears on the market based on its area. Let's say you're the owner of a house and you want to figure out what would be a good market price for your house, right, as a seller. Now again, you can use some kind of a supervised learning algorithm here, where you tell a machine that I'm going to give you a series of labeled examples like this, one for each house, where I'm telling you what the area of a house is along with the price that it was sold for. And this is what the machine needs to predict. It needs to learn to predict the price based on the area. And one simple way it can do that is by linear regression, which you guys said that you've done in your statistics course, where you approximate this pattern by a straight line and you calculate what the equation of this line should be. And the way you do that is you minimize the error, the total error, the least squared error. I'm assuming you know how to do that if you've encountered it before, where you try to um, estimate the slope and the intercept of this line based on which parameters minimize the total least squared error, right? Because there will be some error, because no matter what kind of line you draw here, some of the points are not going to exactly fall on the line. And so, okay, so as I was saying, um, I was mentioning another kind of a supervised learning problem, where what you want to predict is not a discrete class for a document, but you want to predict a continuous price, a real valued price for a particular house based on its area. Okay, and this is also supervised learning problem because you're going to provide a bunch of training examples. You're going to provide this training data to a machine which will take all these examples and then come up with a straight line that will minimize this total least squared error. And then the machine will use this equation for the straight line to predict the price for a new house. So if you have a house which has an area corresponding to this value, then the machine will just use the equation for the straight line and predict what the price is for that particular area. And this will be the estimated value of the price. So this kind of a problem is called a regression problem. In a regression problem, you're trying to predict some real valued output for the given input. Whereas in classification problems, you're trying to predict some discrete, not a real valued, but a discrete class for a given input instance. Now there are a variety of classification problems and there are a variety of regression problems. But I hope you understand the basic difference between a classification and a regression problem. Both are examples of supervised learning problems, because for both kinds of problems you necessarily require training data to train your model, and then the machine will use that model to predict either the class or the real valued output value for a given input instance. Any questions about this? Okay, so that's broadly what supervised learning is, and I hope you understand what this phrase means. And as you can guess, there is also something called unsupervised learning, where uh, you don't provide any training data, and those are a different kind of different class of problems. They are not classification problems or regression problems. The next topic that we'll be looking at after covering classification will be clustering, and clustering is an example of unsupervised learning. Anyway, so